bell for the end of the school day may have rung, but the learning doesn't end there. This is your geography revision session. We're covering Year 8, Module 3, Our Varied Weather. I'm Mr. S and I'll be your revision tutor. The Our Varied Weather module looks at the factors which influence the changeable weather of the UK, such as why we get periods of sunny days which might be followed quickly by brief areas of rain, or why it randomly snows in March. We'll also look at how climate change is involved too. As always, we have 5 elements to look at, so let's start with the atmosphere. The atmosphere is a large band of gases between our planet and space, and it performs a wide variety of different jobs. We're going to have a look at the different layers that make up the atmosphere, starting at our planet and working our way out into space. Our first one is looking at the troposphere. This is a small band of gas between 0 and 12 kilometers from the planet. It holds 90% of all the gases that make up the atmosphere in this small little area. So that's the oxygen, the carbon dioxide, the nitrogen, the methane, all of it. And this allows us to breathe. It creates the pressure that we're expecting as well. And it's also the area that we live in. The second layer is the stratosphere. Now it's very calm in the stratosphere. There's no weather, no strong winds. It's just stable air. And it also contains our ozone layer. The next one is the mesosphere. Now this plays an important role in protecting us from meteorites. So the resistance as rocks travel through this layer causes them to burn up, or to the point where they no longer pose a risk to the planet. And then our outer layer is the thermosphere. And this is classified as closest to space as we can get, and it provides our protection from solar radiation. So the sun's rays, the sun's solar winds are so strong that if this protection wasn't there, then it would effectively kill all life on the planet. And this is also where we get to see the aurora borealis, or the northern lights, in the northern poles and in the southern poles. And this is the reaction of the solar winds against the Earth's magnetic field during that point in the layer. It's also where the International Space Station is orbiting as well. Now, while we have the layers of our atmosphere, there is things that are happening inside there that influence our weather. And most of this takes place within the troposphere. And what we're going to look at first of all are things called air masses. And we can think of air masses as huge bodies or huge blocks of air. And they take on the characteristics of the land and the oceans below them. So for example, on my map here, we've got one called tropical continental. And that one comes from Africa. And you can imagine in your mind's eye, Africa, you'd probably assume to be warm and dry. So the air from Africa is going to be warm and dry. And as it travels north towards us, it's going to bring that warm, dry air to us. So we get weather conditions which are warmer and drier than we'd usually get. So each of these arrows represents a block of air, an air mass that is going to bring weather characteristics to us. There are 2 that we classify as being tropical, so that's going to bring warm, it's going to be hot. The word continental means it comes from land, so that's going to be dry. And the word maritime means it's going to come from over the ocean, which means wet. So when you put the 2 together, tropical maritime, warm and wet. Tropical continental, warm and dry. Polar and Arctic mean cold. So it's going to be cold and wet, or cold and dry. So let's have a look at these in a bit more detail. Tropical continental, as we said, comes from Africa. It's going to bring us our warm weather. It's dry, and it tends to be the dominant air mass in our summer. If we move anti-clockwise, we're going to come on to tropical maritime. This comes from the Caribbean, around places called the Azores. And it's warm, so you can imagine around the Caribbean we'd expect it to be warm, but this is the majority of it is over ocean. So as this air is travelling, it's going to pick up the moisture from the Atlantic. It's going to bring, so that's going to bring us warm, but also cloudy and rainy weather. The next one is polar maritime. So this is coming from Canada. And polar maritime brings us wet, cold conditions. It also brings us a lot of rain. The next one is coming from the north towards moving south, and this is the Arctic maritime. And this brings us wet, cold, and it'll also bring us our snow to the northern half of the UK, so Scotland and northern England during the winter. And then finally we have our polar continental. Now this brings us two different types of weather. During the summer, because it's over land, this will also warm up. So that means in the summer, it's going to bring us our hot and dry weather to the east coast. But in the winter, this is going to come from places like Russia, an area called Siberia. So that's going to bring us some cold weather. So it's going to bring us snow in the winter. Next up, we're going to have a look at two different types of pressure. So in 8.3.2, we're looking at high pressure. High pressure brings us our good weather. So when we were talking about the air masses before, the tropical continental, this is an example of what would be happening here for high pressure. So if we were looking at this on a synoptic chart, so that's like a weather chart, we've got these lines, and these represent what are called ISO lines or ISO bars, and they are highlighting areas of pressure. So pressure is the amount of air pushing down on the surface of our planet. If the pressure is high, that's going to bring us our good weather. And we can represent high pressure by looking at the numbers. So anything over 1,000 millibars of pressure will be seen as being high pressure. But we can also tell because the spacing between our bars is quite big. So the wider the spacing tends to indicate that it's going to be high pressure because the difference between them, the space between them is quite big. And you can see that our highest pressure is being indicated by H here and the cross at 1024. So this area here is going to have the highest pressure, so the most stable air. So high pressure brings anticyclone conditions, which is areas of high pressure. As they form in the upper atmosphere, it's going to bring cold air down. So cold air sinks because it's denser, it's heavier. So it's going to bring it down and it's going to come towards the surface. That's going to keep any moisture from at the surface, so it's not going to form clouds and rain. So the descending air moves in a clockwise direction and it brings long periods of stable, calm weather. So it'll bring us our warm, sunny weather. There'll be no clouds in the sky, just as this picture represents, because all that air is descending. So in the summer, that's going to bring us warm days. It'll bring us heat waves. Might even bring some droughts if we get high pressure for a long time. Clear skies, and there'll be very little wind because these bars are so far apart. It means that the pressure between them is longer, so you're not going to have very much wind. In the winter, it is slightly different. So it's going to bring us cold days because there's no clouds to keep the heat on the surface. The nights will freeze again because there's nothing to protect the heat from escaping. It'll bring fog and mist and frost. We'll still get some clear skies, very little wind, and it will still be dry. Next, we have low pressure. So that's the opposite of what we've been seeing in high pressure. So low pressure, we also call depressions. So the good way to remember this is if you're feeling depressed, you might feel down, you might feel rain and clouds. That's the sort of weather conditions we would get with a depression. So they form when the air in the lower atmosphere starts to rise up. This is because the air near the surface of the planet is warmed up, and warm air rises because it becomes less dense. And as it does so, it's going to carry any moisture, any water in the air up into the atmosphere. And as it gets closer to the top of the atmosphere, it's going to get really cold. And all that water will condense. And when it condenses, just like when you've got a kettle on and it's by the window in the house and it leaves all that condensation, that moisture on the window, that's the same process that's happening here, and it forms clouds, which then rain. So that's how we get bad weather. Warm air rises, all the water in the air condenses into clouds, and then it rains. So our low pressure, our depressions bring irregular periods, so we'll have maybe short bursts of rain or maybe a few days of rain, and then it'll change. So our weather can change really quickly in a depression. but it's unsettled, it'll be very windy, very stormy. If we were to look at that on an isobar chart or a synoptic chart, we can see here that these lines are very close together when you compare them to here, which was our high pressure. So these are really close together, which means the pressure's changing really quickly. So that tells us that actually we're going to get a lot of strong wind. The closer these lines are together, the stronger the wind's going to be. And our low pressure has been indicated by an L, and anything under 1,000 millibars of pressure is classified as being low pressure. So you can see here in the center, 960 is our lowest pressure. The weather conditions that we're going to get, well, it's going to be wet, and that can be from just a light drizzle right the way up to massive storms. The temperature can fluctuate as well. We do get warm weather because the clouds help keep the heat in, but we can also get cold weather as well. The winds will be strong, and the closer those isobars, those lines are together, the stronger the winds are going to be. We get lots of cloud. It may be overcast, it may be dark storm clouds, massive cloud banks. And then we get heavy storms, particularly in the winter. Low pressure can bring really heavy winds and rains for storm conditions. Next, we're looking at what a microclimate is. A microclimate means having an area that has slightly different weather conditions to the wider area. So for example, if we were in Hebburn and it was 13 degrees and the wind was coming from the north, and then we went to the Key Stage 3 garden area in the school and it was actually 14 degrees and the wind was coming from the east. That's an example of a microclimate because something in the area is changing what the weather is doing, and it's usually one of the 5 aspects that we've got on the presentation at the minute. So let's go through each of these in turn. We're going to start with this one called aspect. So an aspect is the direction that a building or an area is facing. Now we know that the sun rises in the east and sets in the west. So during the day, anything that's facing the south will always have the sun, so it's going to be warmer. But if it's facing the north, it's very difficult to get any sunlight because of the direction that the sun is moving in. So I've got this represented on a house here. As you can see, the back garden of this house is in shade. In that one, the house is facing north. So anything in the north here is going to be really, really dark because this building is stopping the light from getting there. However, in this one, the building's been turned a bit. And now this garden is actually facing towards the southwest instead. So it's getting more of the sunlight during the day because this building is now blocking this side of it, not this side because of the way that it's been angled. So if you were in our school, if you were in the car park of the school, that's colder because that's in the north. If you're on the playing field, that's warmer because that's in the south. The next one is surfaces. Now the colour of the surface actually changes how warm the surface is. So darker surfaces, and this is the same for anything, it's not just things on the ground, it's a scientific fact. We have different types of resistance or the ability to retain heat or absorb heat. So darker surfaces actually take in more heat than lighter surfaces. So lighter surfaces reflect the heat back. So in these two examples, this driveway will be warmer because it's darker coloured than this pavement, which is lighter coloured. And again, if we were thinking about things in school, the actual car park itself is made of tarmac. So if you put your hand on that, that would be warmer than the pavement that you walk on to get into the school building, which is a lighter colour. And that's important because during the day, these surfaces will store all that heat, and then later in the day, they'll irradiate it, they'll give it back out into the air, which will warm the air up a bit. So if there's lots of tarmac around in the evening, this will be a lot warmer than this one will be, because this one hasn't been able to retain as much heat. The next one are physical features. And the physical features of an area, such as the mountains, the hills, the cliffs, forests, rivers, lakes, can all influence things such as how much wind we receive or the temperature of the area. If there is a large body of water, like a river or a lake, then it will be cooler because the water acts as a sink for the heat. It absorbs the heat, so it's cooler around the edges of the water, or if you were on a boat on the water. If you were on top of a mountain, it would be windier and cooler. If you were in the shade of the mountain, on the wrong side, so if you were, go back to aspect, if you were on the north side of the mountain, then it would mean that all the sun was being blocked by that mountain. If you were in the trees, you would be sheltered from the wind, but it would also be darker because the trees are blocking out the light, so it would mean it would also be cooler. So the actual physical features of the area can influence this, which brings us on to our next one, which is shelter. So shelter reduces the effect of wind. So going back to the tree analogy, if we were behind it, or if we were in a forest, then we would be more sheltered because the trees are blocking the wind. Or if we were behind a hill, that would block the wind as well, so we're sheltered. There's another one that's not on here, and it's called shade. And that's the same process, but it's for the sun. So if we were, as I was saying, on the north side of the mountain, we're shaded from the sun. And then finally, buildings. So these houses, these surfaces, all give off heat. So buildings act like batteries. They absorb the heat during the day and give it out at night, which means that actually if we live in a city, or if you're in a city, it's warmer there than in the countryside because all the buildings are absorbing the heat and then irradiating it back out at night. So the countryside doesn't have that going on, and therefore it's going to be cooler. And finally, we're going to consider climate change. Climate change is the process of our overall patterns of weather over a longer period of time changing. This can be due to man-made and natural influences, and we're going to have a look at some of both today. But the first thing I want us to consider is the greenhouse effect. The greenhouse effect is a process where the gases which naturally occur in the Earth's atmosphere trap sunlight. We've got this on the diagram here. So we've got incoming solar radiation, incoming heat and sunlight. We call this insolation. Comes in, it passes through our atmosphere, and this darker blue here is going to represent the greenhouse gases. Now they do occur naturally, and they're important because what they do is when heat is reflected off the surface of the sun, it traps some of the heat in between here in our atmosphere, which means that life can be sustained on our planet. If the greenhouse gas layer wasn't there, all this heat would escape back out and our planet would be the same temperature as space, which is absolute zero, absolutely freezing. So it plays an important role. The problem is, mankind has influenced how thick this greenhouse gas layer is. We have, which we're going to come on to in a little bit, created additional greenhouse gases, which has made it thicker. This means that more heat is being trapped inside our atmosphere, which means not as much heat is escaping. And therefore, it's going to start increasing the temperature of our atmosphere, of our planet, to points which are now bad for us. So we need heat, but we have to have it at a right level or it becomes a problem as well. So what's causing climate change? What's causing this increase in greenhouse gases? Well, we have agriculture. So we raise animals, particularly cows, and they produce methane when they burp, and therefore that's going to put more of that methane into the atmosphere. We mine for coal and we burn fossil fuels. These give off carbon dioxide, which is a greenhouse gas as well, which ends up in the atmosphere. Making cement produces carbon dioxide as well. Forest fires burn wood. Wood is carbon, which produces carbon dioxide. Decomposing natural plant material. So this is a natural process. As plants and animals die, they decompose. That gives off methane and carbon, which ends up in the atmosphere as well. When volcanoes erupt, they're putting out ash and carbon into the atmosphere, and that's a natural thing. And evaporation from lakes, rivers and oceans put water vapour into the air. And that's actually part of the greenhouse gases as well. So you can see here, the ones with H's are all human. So agriculture, farming, coal mining, burning fossil fuels and making cement, and some forest fires, which are set by man, are all human. Whereas some forest fires, which are started by nature, natural forest fires, decomposing animal material, volcanoes, and evaporation, are all natural factors. So if these H's ones weren't there, then the greenhouse gases would be at an appropriate layer and it wouldn't be an issue. But because we're doing all these things here and more, our greenhouse gas layer is increasing, which is increasing the temperature of our atmosphere. And the effects can be seen both here in the UK, but on a wider global scale as well. We're going to start seeing, and we have seen in the past, warmer summers, and that ends up with increased heat-related illnesses, particularly the very young and the very elderly can't regulate heat as well, and therefore they suffer more. So they might have heat stroke, they may end up completely dehydrated, or even deaf from too much heat. We might end up seeing more immigration to the UK as people leave more environmentally risky areas such as Africa and certain parts of southern Europe, which are more prone to drought, so a lack of water, and move towards Western Europe because we are slightly cooler and can manage it better. But there are some positives to this as well. As our temperature increases, we could see farmers growing olives and lemons and fruits and veg that need more heat. We'll get warmer summers, which might mean that we get more tourism, which is going to mean more money in the economy as people go to the coast. But it might also mean that we have a decline in income from from ski resorts. So thinking of Scotland, as the snow melts on the mountains. But we also will see a migration of species away. So our natural species might find it too warm and have to move somewhere else. Or we might start getting more species from further south that like it warmer coming to the UK, which is a negative because it means that we're losing our natural environment. And there's also a risk of increased flooding in rivers and from the coast as our sea levels rise, which is linked to this one in the world effects, and that's the melting ice in the ocean, making the sea levels rise. And you can see here all of these are influenced either socially, to do with people and families, economically, to do with money, or environmentally, to do with the natural world. For the impacts on the world, we're going to see more tropical diseases spreading further north and south. So while they've normally been around the equator, because things like malaria need warm, moist conditions, the UK has never been anywhere near having malaria because the conditions aren't right. But it's going to start spreading that band, making it bigger and bigger and bigger as places further away from the equator start to get warmer. So we might see more tropical diseases spreading north and south. There's going to be increased tension and conflict as water and food become more scarce in these areas because of the increasing temperatures, meaning that food production, growing crops, becomes harder. Crop yields are expected to decrease because of the impact of a lack of water and increased temperature. It's not what these crops are used to growing in. Tourism problems, areas that rely on skiing might not have any snow anymore or less snow. Safaris, animals not enjoying the increased heat or the vegetation changing, which means that people can't make as much money from this, are at risk from climate change. Increasing sea levels, some predictions between 18 and 59 centimetres. It doesn't sound much, but most places, most coastal landscapes cannot manage more than 30 centimetres worth of ocean to air change before significant flooding. In some places, it's less than 10 centimetres of flooding. The ocean circulation may be disrupted. So the ocean circulation is a band of water that travels around the Atlantic, in our case, picking up heat from the equator and moving it further north, which allows us to maintain our temperate climate. Without it, we'd be a lot colder, which means that it would disrupt a lot of what happens in the ocean in terms of life, but as well as impacting on our ability in the Northern Hemisphere for America and for Western Europe to survive. And we've already mentioned the melting ice, which would lead to a loss of polar habitats as well. That's it for today, but don't forget to complete the home study questions to test yourself. Goodbye.